Hey, g'day, it's Presso. Thanks for stopping by. Now this is episode 2 of building a float lock vise for your drill press table, and there is a playlist. It's up there now. You can go back and look at episode 1 if you didn't get to see that. And in that first episode I made some castings for this style of vise. Now if you don't know what a float lock vise is, it's a type of clamping arrangement that goes on the drill press table, and it allows you to reset and reposition the vise very quickly, but it also holds round, square, rectangular and sheet stock very securely. Now it's not my idea, it's been around since it was patented in 1955 I believe, and a lot of YouTubers have made different versions of this vise. The one that I want to make is a fairly close replica of the original float lock vise and the one that's still being made by a company called Wahlstrom. But before we get on to any machining today, I want you to have a close look at the bench here. I'll show you some details of the design that have cropped up between the first episode and today. This is a 3D render of the design that I'm going to work to, and I've got the 2D drawings of this design as well, and I'll make the 2D drawings and also the STL files for the split patterns available at the end of the build. Now I want to be sure I've got all the revisions and all the corrections done before I make that public. Now when I was designing this, I was using this drawing here. Now this can easily be found on the internet, and it's got a sort of an exploded view of the whole design here, but it doesn't show any detail of what's happening in the bar of the clamp. And this is the mock-up that I made, and I was trying to figure out how you could reposition this jaw quickly and easily. So this is essentially the fixed jaw, and this is the moving jaw. This is the one that you tighten with a handle on the end of it. Now the best I could come up with was a set of drilled holes, and these are inclined at 45 degrees, and a pin can drop into each hole and allow you to reposition the jaw at 9mm intervals. But that's not how the original worked, and on the videos that I watched of this particular clamp and people using it, what they were able to do is sort of reposition this jaw quickly, and it sort of ratcheted along this bar here, and that's the thing I couldn't figure out. Now a couple of people helped me here. One of them was Chuck Bomarito. He's got a YouTube channel called Outside Screwball. He's got the original Wahlstrom vise, and he sent me some detailed digital images of what's going on in the bottom of that pocket there. Now as soon as I saw the photos, I worked out what I was doing wrong. Now another person helped out, and that was a gentleman named Martin. His YouTube name is MartinE63. Now he sent me the original patent numbers, and this patent was filed in 1955, and it had a lot more information than the drawing that I was working from, this one here. And there is also a more detailed view. That's this one here, and you can see here that these holes, instead of being fully drilled holes, which is what I was trying to do, these are like half moons, and they're positioned so that only half of the diameter is drilled into the bottom of that pocket there. So when you pull on this little U-shaped pin here, you can disengage it and move the jaw quickly, but if you just want to slide it very quickly toward this jaw here, it will just sort of ratchet along. So I've modified my design to work this way with this detail here, and hopefully we can replicate that quick action. But what we need to do now is get these castings. We'll get over the milling machine, we'll get these cleaned up. So we're just going to get some reference surfaces on them, and then we'll figure out how we're going to attach these steel jaws to the castings. First job in machining these is to get both sides flat and parallel. I'll reduce the thickness this way, the vertical dimension, down from 39.2, which is what it is now, to about 37. The finished dimension is 36, but I'll do that later on in a fixture. So when I've got two parallel sides, I can turn this in the vise that way, machine the top, bore it out to the correct size for the main bar, and then I've got a series of 4 holes which I can drill. Now these will hold the steel jaws on, but they'll also help with the fixturing for later on. That finish isn't brilliant, but it doesn't matter. This is just to get a flat face so we can flip it over in the vise now. All the finish machining will be done later when we got this fixtured. Alright, I'll do the other one the same, and then we'll stand it upright in the vise and we'll machine, actually we won't, we're going to machine this surface here, then we'll turn it over. Alright, like I said, I've got to clean this surface up next. Now I totally forgot about it, but I do need to have an accurate flat clean surface here. This is where the steel jaw will be screwed on later on. So what I've done here is I've pushed it up hard against the fixed jaw, and I've got a piece of round copper bar stock in between the moving jaw and the casting, and that will ensure that at least that back face and this one are square. Now I've run an indicator over this and done a bit of tapping. It wasn't quite right sitting on the bottom of the vise, and with a casting you're never going to get perfect, but I'm now within about 0.2 or 0.3 over the entire length, and I'm going to run a multi-insert face mill over this now, and that'll give you a nice clean finish, and then we can flip it. Well, got a pretty good finish with that multi-insert face mill, and I was being a bit cautious there because I don't have a lot of extra material in this vertical height. So I just wanted to clean up, and that's all. So what I'm going to do now is flip that over and machine this face here and bring it to that finished dimension. I'll just leave the Z-axis set where it is, and I'll do the other one. Now I just need to blend that a bit with the file, and there's a bit missing off this corner, but hey, it's a casting, what can you do? So what I need to do now is center up over this bore here and bore it out to fit the main bar, and then I've got to drill a pattern of 4 holes. So there'll be 2 in these 2 corners up here, 2 down here. They'll hold the jaws on later on, but like I said, they'll also help with the fixturing. Need to go ahead now and open up that bore to 20mm diameter. Now this is a chord hole, so it's not particularly accurate or round or parallel through its bore, So I ran an adjustable reamer through that just to knock off the high spots and give me roughly the same diameter on both castings. And I've made up this little aluminium plug here. Now it fits into that bore now, and I can run my indicator down onto this outer surface here, and we can center over that bore. Now I've already done that, and we're within, say, 200ths of a millimeter. It's less than a thou. So I'm satisfied that's pretty good. And I'll go ahead and bore that. Now when I change out to this other part, I'll need to do the same process, but only in X. The Y dimension should be close, but we'll reset when we get to that point. Now I'm using the automatic down feed on the Bridgeport, and that's why I had to stop there. I was a bit worried I was going to hit that little projection of the casting here with the top of the boring head, but looks like we're clear. So I'll go ahead now. I'm just going to open this up. I've got a little test piece of steel that I can drop in there just to check the fit as we go. So we're just going to gradually open it up and we'll check it, and we'll try and get it to be, say, I don't know, like an easy sliding fit. I think that's what we're looking for. But yeah, getting a really nice finish in there, that's good. Alright, now this little piece that I've got here is actually a little bit smaller than the bar stock that I've got for the clamp itself, but that slides in quite nicely now. And I think the bar stock that I've got, once I dress it and clean it up, polish it, I think that'll be a really nice fit. So totally happy with that. So I'll go ahead and do the other one now. So this is the stock that I'll be using for the main bar of the clamp, and you can see there that that's a fairly firm fit. And like I say, when I clean this up, get the rust off it, I think it'll be perfect. I'm just about to drill the 4 holes through the casting here, and I've got a spot drill and then put in a clearance drill. Then I've got a counter bore, and instead of changing the tool for each hole, I'll just go around, do each operation 4 times and then change out the next tool, do that 4 times. So I've got all my locations in touch DRO. I'll show you how that works. So down this side here you can see 5 locations. One of them is the actual center of the bore that I've just done, and then the other 4 are the 4 drilled holes. And you can also see on the visual display here each of the hole positions, and as you move toward the next hole, the DRO here, the 2 axis locations, will start to count down to 0 as you get close. So let me show you. So let's just imagine we just drilled the first hole and I want to move to the second location. And as we get close, you'll see the Y change. It starts to count back to 0. And then we drill that hole and then we move on. We do them all in turn. So let's do that now. So that's all 4 spot drills done. Now I didn't think ahead, and when I try to drill through with this clearance drill, I'm going to drill into my parallels if I go right through. So I'm going to stop just short and then I'll finish that drilling operation later. and then we'll swap out and we'll do the counter bore. So I've set my quill depth stop there so I don't drill into the parallels, so I'll go ahead and drill all 4 clearance holes, and I'm going to swap out for an 11/32 end mill, and we'll use that to do the counter bore for the socket head screws. Okay, we'll swap out for the counter bore now. I'm using an IPA as a coolant here. It's a lot less messy than soluble oil. I forgot to record the 2 counter bores down this end here, but it's the same process. These are just shallower, they're only 1.5 millimeters deep. These 2 up here, the head of the socket head screw has to be below the surface. On the other jaw there's a feature that goes over the top, so they're 0.1 of a millimeter below the surface. So I'll go ahead and do the other one off camera, and then we'll make the steel jaws. Now I knew you'd want to see this, so what I've done is I've assembled the pairs of castings. I've put socket head screws through each of the holes, and that aligns them, keeps them together. Now if I've done everything correctly, this little steel fixture piece will just slide through the bore. Well, hey, so that's a good thing. Now what I need to do is go ahead and get these steel jaw pieces roughed out. Now these are way oversized at the moment, so I'll get them close to size, and then I've got to do the same thing. I've got to bore that main hole and then put the 4 holes in, but they'll be threaded holes this time. And then I can assemble each casting onto its steel jaw piece, and then we can machine the profile, the perimeter, so that each pair is exactly the same. So with these steel jaw blanks here, I've got 2 of these. These are machined just slightly bigger than the aluminium casting. So what we're going to do is to centre fine across the width of that stock there, and then set back from this machined end, which is up against the stop here, half that width there. That'll give me the centre of the 20mm bore. So we'll drill and bore that out, and then I'm just going to punch 4 holes through the corners to match up with the holes that are in the casting. So close. So close. Alright, let's do a trial assembly, see how that looks. Now I've only put 2 socket head screws in there at the moment. There'll be another 2 to go down here later on, but I wanted to check the fit. Now that is relatively firm. This one here is a little bit looser, but that's sort of the fit that you want. It should just slide easily without any shake or rocking. And what I need to do now is to machine all of these outer faces and get the perimeter cleaned up. Now you might say, well, it doesn't really matter, does it? Just sort of skim them. But one of the key features about a float lock vise is that you should be able to position it in 3 different orientations. So like that, you should be able to flip it on end, or you should be able to flip it over and lay it on the other side. And in every orientation, this steel bar should be the same relative height above the drill press table. So no matter which way you flip it, the bar is always pressing these jaws down flat onto the table. So for that reason, I need to be able to work out some sort of fixture so that I can machine the faces, these outer faces, relative to that bore accurately. So that's what this little gadget is for. I'll go and get this set up in the Bridgeport, and then I'll show you what I have in mind. And hopefully we can get these all cleaned up, and that'll be the job done for today. Now this is the setup that I'll be using to machine these parts. So what I've got here is a very well used piece of fixture plate, but I've skimmed that, so I've got a flat surface on top there. And this is the part that I showed you before, and I was using that as a gauge to check the size of these bores here. And that's been screwed down with a stud into an M8 threaded hole in this plate here. There's another M8 threaded hole on top there, and I can assemble the part onto that post there. And then I've got a big aluminium washer and an 8mm socket head screw to clamp all of that down. Now that's not enough to hold it, we need some other constraint there. So at this end of the fixture plate I've got 2 more holes, and these are sized for M5 socket head screws, and I can fit them up from underneath and tighten those. So I'll get all that snug down. And I've got this big 18mm solid carbide end mill. This is about the longest cutting tool that I've got that will reach down onto that fixture plate there, and it will just clear the jaws of the vise. So I can use that to skim around the outside. So what I'll need to do is to offset from this center. So I've got this set up on the DRO at the moment as 0, 0. And if I offset 27mm both sides and the end, that will clean them up. And then I've got to offset 91 to get this end here. So I'll get all this tight, and then we'll set up and we'll just do a few conservative cuts to see how it's behaving. I'm going to try doing this end first. It's not all that critical, and it's a bit shallower, so we'll see how it behaves. Now my DRO at the moment says 91.4. We've got to come into 91. Hopefully we'll clean up both the aluminium and the steel part, but we'll just take it in stages, see how it behaves. That seemed to clean up pretty well. I've still got 0.4 of a millimeter to come off there, but that gives me some confidence to go ahead and do the taller sides there. So we'll get all that done, and then we just swap the parts over. If we don't touch anything, just use the same 0, 0 down here. We should be able to reproduce the same dimensions on the other part. Well, that seems to be going pretty good. This carbide end mill is second hand. It was one that was given to me by a viewer, and I think it's been chipped or damaged, but it's doing a good enough job. And I'll do the back face now because you won't be able to see that, and then I'll swap out and do the other part. But yeah, it's coming along fairly well. Okay, well, I've done the back, so I'll just take this one off and see how it looks. Alright, needs a deburr. I'll do that, and I'll do the other one, and I'll meet you over at the bench. Well, I've just deburred everything, and I've assembled everything that I've got so far. This is just a mock-up of the shaft. But what's important here is that when these two surfaces go together, that they touch perfectly, all the way from the bottom to the top, which they do. And you'd also be entitled to think that these surfaces on this front face and the back face and underneath here would be exactly coplanar, but they're not. Now, it's probably only like about, I don't know, 5 thou, but I could feel it. And this was the fixture plate that I used, and I suspect what happened was that when I made this post here, it was a bit undersized. You would have seen how easily that slid through that bore there. And I think that when that big carbide end mill hit these surfaces, it just kicked it sideways slightly, and it got out of alignment. Now, does it really matter? I don't know. When it's on the drilling machine table, lying on its side like that, it's probably fine, but I really would like these to be exactly coplanar. Now, what I'll probably end up doing is to put an arbor through there and bolt it up really tight, and I'll fly cut these surfaces. So I'll do that one, this one underneath here, and the one on the other side. Now, the finished dimension is meant to be 36. Now, if it works out to being like 35.8, probably doesn't matter that much, but I do want them to be completely coplanar. But for now, I think that was, relatively successful. So what I'll do in the next episode, I think, is we're going to try to cut the V-grooves in these jaws. So there needs to be one across the jaw and one lengthways down here, and they've got to be 90-degree V-slots, which is going to be interesting, especially given that we want the V-slots to line up perfectly both ways. So just using the end mill tilted over at 45 degrees probably not going to work, so I'll need to work out something more accurate than that. But for now, I think we're going to wind up here. Now, just before I go, I'd like to thank everyone who gave me some positive comments after the channel update that I did. so many people appreciate that, you know, just by watching the videos that I'm doing here, that you're contributing to Bulvos, which is the charity that I want to support. And looks like this month's income from the channel is going to be a little bit more than what I got last month, so it's going to be great. So to celebrate that, I'm going to finish up with some footage of some animals around the garden here, and our little buff banded rail that's been more regular in the garden. We've called that one Buffy. I believe they're also called turbo chooks, and a chook is the colloquial Australian name for a chicken. So yeah, let's go and have a look in the garden and celebrate the wild animals. Okay, Espresso signing out. Catch you on the next one. Cheers. Got a couple of big male eastern greys in the paddock today, and there's a female with a joey that's probably in season, and that's why these males are hanging around. All that grass trees growing, new flower spikes too. These things are really ancient plants. Well, not these, but the species is very ancient. Probably around when the dinosaurs were here.